Good. Hello, hello, hello.
Hey. Hi everyone.
Hello, hello, hello. Okay.
We're finally there.
Finally. Oh, the wait was so long.
Actually, 2 weeks.
2 weeks.
Even longer for me, like it was.
Yeah.
It was 1 month at least. Yeah, 1 month. Because I made January 8th live stream for the...
Yeah, and then it was Teme and I.
Yeah, truly.
Okay. So we have... Hello, everyone. We have some great news today.
Exactly.
Some great news. But first, before addressing the great news, I still want to say that I'm kind of disturbed because we switched place.
Exactly.
And so
it's a bit disturbing.
Yeah, I'm not at my place.
So
I
you guys can have the full
my full face.
Potential to see the face of Nicolas.
My awesome cut.
And I'm
isn't it nice? Yeah. Anyway,
nice and I'm a bit in the backwards. That's cool. I'll leave you all the place today.
So the great news, the great news is not related to the product. Unfortunately, the great news is more for us than for you.
It's gonna be for you too. In some way.
No, the great news is that we finally have a proper internet.
So normally everything should be fine for the live. No lagging, no disconnections, no refreshing, no back and forth from Twitch to YouTube.
So yeah, it should be stable.
Yeah, it should be stable. Yeah.
And is the sound good? Because I'm still struggling with everything, so I just reduce a bit the music. I think it should be nice. It should be nicer now.
Just tell us in the stream, in the comment, like if everything's going good with the sound.
Yeah.
Just for us to know it's good.
And also, it's good. Okay, nice.
Perfect then. Perfect.
Also,
thanks.
Since the internet is better, that also means that we have way less delay with you. So when you're asking question, we can answer quicker, which is a great news.
Which is totally
because
great news.
Having like a 20, 30, 40 second delay can be very annoying for both you and I. So So it's nice to have like a more direct connection. Anyway, so.
What are we going to talk about today?
It's in the title. So today we are gonna talk about engineering filaments. So more specifically, we're gonna define what we call an engineering filament, but more specifically, like weird filaments in a way.
Yeah,
not weird, but like specific tricky ones, use filaments.
Great. So shall we start by defining what do we hear, what comes into our mind when we talk about engineering filaments?
How do we define them? I mean, at first I'm just gonna to be like a bit more clear. We're gonna talk mostly about carbon fiber filaments. So all the kind of carbon fiber filament that we have, the PLA, the PETG, the nylon, all these filaments, and what we are gonna use them for. Expensive filaments. It's a way to put it. It's a way to put it. Yeah.
But it comes with quality, and it comes with also with advantages.
Yeah.
It's not purely price stuff.
No, you pay for something.
Like always.
And just for Matey, the soundtrack is Octopath Traveler. It's kind of giving a Lord of the Ring vibe indeed. And tell me if the sound is too loud, by the way. So, expensive filament. We were talking about expensive filament and carbon fiber.
Expensive? Can I say expensive? Really? There's some of them are not that expensive. To be honest.
we're gonna talk about it, but basically, some of them are pretty cheap. Like there is alternative for every usage, and of course if you want like the top of the top, the more like complicated filaments, also complicated to print, the more like off the best filament, basically it's gonna be a bit more expensive than PLA, but there is some very nice alternative like the PC that we're going to talk about a bit later, which is very pretty cheap.
Just to reply it quickly to Builder's Mark. Sorry. Today mainly the topic gonna be about all the Sunlu's engineering grade filaments. What are they? What can they bring for each and every one of them? What kind of applications? Because they are quite tricky sometimes. What are the good tips? We can say like, well, what are the tips to print them and to succeed in printing with them? Yeah, basically they're gonna be it.
Yeah, and just a quick address sheet. Technically, the giveaway it's gonna take a bit more time. I'm on it. I'm the one sending it, so it's my fault if you don't receive it, basically. But like, it take a bit of time. We are sending everything, so just stay tuned, and I will send everything. And how much does the printer play a role in using engineering filaments, like in the strengths and like? It's kind of a tricky question. Like, of course, both the filaments and the printer play a role in the quality of a print. You can see that like a cheap printer will have like visually, you can see that it will have more time, hardest time, to print a filament. Print a part, but most importantly, I want to say that some filaments, like the PA, require a very high temperature, or some of them require an enclosure. And so, if you have like a cheap printer, it basically cannot reach a certain temperature, so it won't be able to print PA at all.
Some of the basic requirements sometimes may be not reached by some kind of
exactly
lower end printer. So yeah, you will miss on that part too.
And there is also like some accessory that will make it easier to print. We will go in the detail a bit later, but for example, the bed. It's almost mandatory to have certain type of bed, so you need like if you have a printer with a non-removable bed and you use like blue tape to stick your print, it can be very tough to print nylon. You need an enclosure, as I said, but in terms of very like strength, if you manage to print with the printer, then technically you're not limited by the printer. Technically.
Yep. That's a good introduction. Like, should we dive more in? Did we cover everything for the introduction?
Yeah, I mean we can, as we said, we're gonna talk about every single filament that we consider engineering filament. We're not gonna go into too much detail. I mean, we're gonna go into detail, but I don't want it to be too boring. So,
yes, and when you dive into details and dealing with several type of filaments, it can take hours and hours.
Yeah, exactly.
And,
and anyway, we have also all kind of print to show you behind us.
Exactly.
So it's better to have example. Before we dive into it, I forgot to say that as always we have a giveaway. I don't have it with me, it's in the other room, but what are we gonna give away is a filament connector. So we have two winners, as always. One will win the filament connector and 2 kg of engineering filaments.
Yeah, this is the topic of the day.
And the other winner will win also 2 kg of filaments. I still don't know exactly what it will be.
Thanks.
Oh, thank you. The filament connector. Nice. I won't show how it works now because the next stream I think is about
sustainability and respect of the environment and ecology,
everything. So on the next stream we will talk more about
this baby.
The filament connector. But anyway, that's also what you will win today, so stay tuned. at the end of the stream, as always.
And yeah, I think you forgot something we discussed about because now the internet is working well. So Nicolas has some idea of doing some another kind of live streams. Can you tell us a bit more about this?
Yeah, I mean, it's not totally defined yet, and we also talk about it a bit on the previous stream. But basically, since we have internet now properly, I can stream on the day, during the day, and way more often. So we will do more stream only on Twitch at first, I think, because it's easier. So follow us on Twitch, of course. And we will do a stream out of the usual 2 weeks stream. So it will probably be every week. I don't know exactly when we're gonna do that during the week. Maybe not on Thursday, but maybe on Monday, Friday. And it will be more intimate stream, more like non-formal stream. And we will be about more like, we'll get more technical. We will slice parts, we will engineer parts, and we will print. It will be more of a like DIY, more straightforward stream. So stay tuned for that. It's gonna start soon. Maybe next week, maybe in 2 weeks.
Yeah,
I don't know
maybe
yet.
not gonna be restrained by the 1 hour time frame that we are trying to respect for this kind of live stream. Maybe Nicolas will take a bit more time to explain.
It's like, yeah,
and
it's as we feel. Like,
yeah.
If in 3 hours we are bored, then we will stop and we will see. Anyway, I saw some question that we didn't answer regarding the filaments.
Yeah, I'm trying to find the price for the filament connector in the US. I lost track there.
Wasn't it 120? I think it's
filament connector is not that expensive usually there.
I don't remember.
If Teme can help us with this. Does industrial grade 3D printer supposed to give best result with engineering filaments?
Well,
it's supposed to be like usually industrial grade printers they cost like crazy, and they are able to achieve high temperature, they have higher standards. So if we're talking about nylon, we're talking about PC ABS, or those kind of they should be able to handle better those
the
filaments.
Thing is,
but where is the cost really worse? The results that it's something that
the
I'm
thing
unable
is
to answer.
I don't know much about industrial printer as like a very industrial, like the thing that costs like 5,000 more than that for very like for company. I don't know much about them, but I guess that for FDM it's mostly gonna be printer that are more reliable, that are bigger, that can print quicker. But I'm not sure that it's gonna be very like you cannot achieve a certain amount of quality with FDM. If you want other technicality, more detail, you will go on a different kind of printer. And in the industry, for example, they print a lot in metal. And when you print in metal, it's not FDM, it's laser printer, for example, powder printer. So it's like a very different kind of printing. And on the same thing, Chris asked if it was required to have a Bowden to print the engineering filaments. It depends of the filament. For the nylon, it's way better to have a Bowden. I mean, in general, it's always better to have a Bowden, but it's not the most important thing. Usually, as we said earlier, is that the nozzle needs to reach a certain temperature to print nylon, and usually the non-Bowden printer are also the one that don't reach the high temperature. It's not related, but it's just like, since they are cheaper, they also achieve less, like lower temperature.
Great. That's a great explanation.
I'm speaking too much. I
No, it's
always
okay.
speak too
No,
much.
it's okay. It's okay. I was convinced by your answer too, so it's nice.
Yeah.
Well, I think we should start by speaking about the filaments a little.
Yeah.
Oh, you want to take another? I think there's someone asking also. Will be possible to add an option? Do not include filament clips in the shop. I already have a big enough collection of them, and oh, yeah.
I mean, we can probably talk about it in the next room about the environments. Yeah, but yeah, indeed, we always give a little clip to attach the filaments to the spool, and yeah, it can accumulate a lot of clip. Maybe we will found some idea of what you can do with the clip to reuse them. Could be good. Is there any good looking engineering filament? Yeah, that's we're gonna talk about it.
Yeah.
I mean, I think maybe we're gonna start with
and basically the one I wanted to start with basically one of the two is basically the one I think personally is the best looking engineering filament. It's maybe not not the one having the best mechanical properties, but in terms of finishing and look, I really have a
you have something for it. Yeah,
I really have something for it. Yeah, actually. The first one we want to talk about is maybe you guys are really familiar with it already. Is the PA6 or nylon 6 carbon fiber. We at Sunlu we have a lot of carbon fiber filament, and that's the first one. Like it has good features of resistance, mechanical resistance, good properties. That's also I think one of our best. Not I think I'm positive about this. That's one of the best temperature resistant filament we have.
Mm-hmm.
And but it can be a bit tricky to print with.
Yeah, basically there is two. I mean, we have three, but there is two nylon filaments with carbon fiber right now. For us, it's the PA6 and the PA12, and then there is the Easy PA that doesn't have carbon fiber. And you were asking if there were any good-looking engineering, and usually the carbon fiber one are very, very good-looking. I mean, we have example that I'm gonna try to grab them.
Don't try. Okay. And usually those filaments fit well into application like prototyping, or if you have to swap some part in here and there, maybe in your car. It's mainly used in automotive industries. Maybe not the one that's directly in contact with the engines, but they defend themselves very well in those kind of industries. And
I mean, that's the whole purpose of the engineering filaments. That's what we call engineering filaments. It's the one that have the best mechanical property or a specific property that make them very unique and very useful in certain type of situation. Basically, it's not the filament that you're gonna use to print just like a little figure or something just decorative. I mean, you could, but it's not the main purpose of the thing. We have examples. So this is PA12 and this is PA6. Exactly. I'm gonna show you a bit more detail later because from here you can obviously not see the difference. And so what's the number 6 and 12 mean in the PA6 and 12? It's actually in the composition of the material. It's a bit tricky. We're not gonna go too much into detail because it's a chemical thing, and I'm not a chemical engineer.
Yeah, true. Yeah,
no, was kind of my weakness. But basically, PA6 have twice as much carbon as PA12. There is two times the amount of carbon in the PA6 because the string of chemical molecules are attached between them are shorter in the PA6 and there is more carbon in it. And so they result in a different behavior between the two. Basically, the PA6 is a bit rougher, and it also have better mechanical property. Usually.
Better resistance globally. Yeah. Elongation resistance, bending resistance. On those kind of settings, on those kind of data, he has better. Yep.
The only withdrawal of this is that since it have more carbon in it, it's also more sensitive to moisture. It absorbs more moisture, and it's harder to print. And basically, you need to dry it. I mean, you need to dry both, but this one is more sensitive to humidity. So it's like you need to dry it more in a way. And the PA12 is way easier to print. And I'm gonna try to show you. I don't know if I will succeed, but basically the PA12 have sharper detail. So you can note that the two of them are made after PACF. So there is carbon fiber in it. So that's why it gives kind of this matte finish. Ooh, almost there. Yeah, you can see the texture finish. And it's kind of glossy, kind of matte. It's not like its texture. It's really nice. And this one, I don't know if you will see much difference, but this one, so the PA6 is a bit
rougher. It's not as smooth as the PA12, and see?
The edges are a bit rounder. It's a bit trickier to print, and it's a bit rougher, but you can still see well, it's out of sync, but it's still moving. It's still moving, and these two. So I like the screw for this one, but if I manage to put it nicely, it's still moving too. Yeah. Anyway, so what I was talking about, I don't remember already.
Oh, you were explaining the whole molecule difference between the two. And, as the PA6 contains twice as more carbon, because carbon is tending to absorb more moisture, and so de facto is more hydrophilic than the PA12.
Exactly.
And the PA12, the good part of this is that it tends to be lightweight. It's lighter, much lighter than the PA6. Easier to print. Nicolas just said it. Much less tricky, and the global finish of it is really nice.
Yeah, it's very clean.
Most of the time, you don't need post processing. That's the drawback of some of the drawback of the PA12 comparing it to the PA6 is that it's less heat resistance. Like I just gave the number of 200 degree for the PA6, 205 degree for the PA6. This one is 175 degree resistant.
That's kind of like, it's always the same thing. You always have to make compromise. And so one filament have advantage toward another, but it won't be like, it will lack some parts. And so PA6 is better overall for the strength, but it's harder to print and you need to dry it more. But keep in mind though that you always need to dry the PA. Like whatever it is, you always need to dry it. Even when you're printing, it's like almost required to leave it in the dryer while you print it. But yeah, there is always like, you have to make compromise. I just wanted to answer some quick questions that I saw that I ignored rudely. About the company, published the research data. I don't know if we published the data of the research, but on the website you can find like the data sheet of every filament, how we tested them, like the strength, the tensile strength, every like almost every data that you need. But in terms of research, I don't think we publish them.
Yeah, I don't know what you I don't know what you understand about the research. Actually, if you want to be more precise, we can we can know what we are talking about, because as Nicolas said, the data regarding the all the tests for filaments, for resins, are in the datasheet, and basically the process is all the same. Like you have several machines to test several properties, and the tests are all the same, like for every filament. That's why we determine one filament resistance from this filament to another, and this is public. We can say this is on our website.
Yeah.
The research one, maybe we'd like you to be a bit more precise about what you're.
And there is a norm around like how you test the filament.
Exactly.
So that's what Mathieu said, and that way it's easier to compare the filament with each other, because you know like what filament like perform the best and this kind of thing. Also, someone asked if this is an engine. It's a weird engine, but it's an engine. Someone asked about the waterproofing of the filament, and I guess it's maybe a good time to compare it to another filament,
sure.
Because I forgot the EZPA, but basically there is filaments that are better for waterproofing and for outside usage. Yeah. The PA is still very, very good at that. Sorry, when you print it, not before, because before printing, as we said, it's very sensitive to humidity. But there is better filaments for that. As we said, it's all about compromise. And I wanted to talk about the PC, maybe.
Yeah.
Or maybe we can talk about it a bit later. I don't know.
Nice. Now it's good. That should be good.
The PC. Also, basically, the PC is a new filament that's not out yet.
Yeah, the PC-ABS, exactly. The PC-ABS is a new filament that we are developing. I think it will be released around March, if I'm not mistaken. Yeah, most probably going to be out in March. And basically, you can understand it in a fusion between PC polycarbonate filament and ABS filament. And it brings a lot of good properties. So as for stiffness, it is wear resistant. It is also quite nice for heat resistance, although it doesn't go as high as the nylon. Yeah. But it defends itself quite well on that topic also.
And I don't remember who was asking about it earlier, or who was saying that, but the PC is the good example for that, is that it's also a cheaper filament.
Yeah.
So see, there is always like...
There's compromise.
Yeah, there is compromise.
All the time.
There is always something. And so if you don't need as much strength as nylon, the PC ABS series could be a good option also. So that's a good thing. It's still very tough, and way tougher than other filament that we're going to talk about a bit later.
Sorry, I just jump up to one question from Alex. As is something you are planning to do also for the office. Like, what filament is the best for a tool holder?
Oh yeah. Well, I'm a bad example then, because the filament I chose for the tool holder
is not engineering filament.
It's a PLA. Yeah. It depends of the tool holder and of what you want to do. Because, for example, earlier I saw someone was asking about I don't remember. Oh no, it was It was about the mount on a bike.
Yeah.
So okay. Currently, I'm printing the tool holder, a pegboard, the one that you fix on the wall and you attach all your tools. And this one, since it's screwed on the wall and it's pretty fixed, and there is like the load is very like well distributed on the thing, it doesn't need to be very resistant. Like it doesn't require a lot of strength. It requires more resistance towards like the UV, for example, or the moisture. So that depends of, you have to think about what will hurt my print basically. And if you compare it to the mounts on the bike, this require way more strength, because when you're riding, you have bumps, you have like the weight of the phone, it move, there is weather, there is
sometimes,
so this require much more strength. So for example, for the mount on the bike, I think I would use a PA, probably a PA12, I think, or PA6. And for the tool holder, I would use something more like, I mean, as I said, I'm using PLA, but I would probably choose something that I like in terms of color or finish, that I found visually appealing for the workshop. So yeah, it depends on the application, basically.
There's a question from the Real Crytek. Is there currently any plans for ABS glass fiber or ASA glass fiber? There's something, we saw something earlier today. There's a plan for Insunlu to have ABS glass fiber. We cannot say too much about it, but
was it ABS glass fiber?
I think I saw it was ABS.
Or was it PA glass fiber? I don't remember. Anyway, there is glass fiber filaments
that will be released maybe later on this year. Yeah, maybe mid-year, more probably Q2. And
that's it. You can use PLA plus for the perforated wall for the tool. It depends on the application. It's always the same thing. You always have to ask yourself, okay, what do I want to do, and what will I say it like it's quite trivial, but what will hurt my print, basically, what will make it break, and then you choose your filaments regarding that. How is it in Germany to do an R&D on a personal project? Do you have to put on a big buck for it? I'm not quite sure I understand the question. What do you mean by on a personal project? Because, for example, at Sunlu, the R&D is not made in Germany, it's made in China.
Yeah, it's all made in China, yes.
And so we have like an engineering team designing and choosing the new filament, designing the filament and the material.
Basically our function here is also to give Chinese team good ideas based on your comments, based on what the market is, what the market trends are, and the main work still remains in China for this. And that they choose, for example, the glass fiber. For example, we're gonna talk about later, but flame retardant filament. We knew it was a big thing for a long time, and we didn't develop this fast enough at Sunlu. And this, thanks to your feedback, thanks to the feedback you gave us at, for example, at Formnext, at fairs, online, through your comments, that we are able to feedback this to China, and then finally we got something to show you soon.
And I mean the filaments is kind of a rabbit hole. Like there is so many type of filaments, so many color, so many finish,
and so many for such several applications, and application are also very numerous.
So and, we are always happy to have a lot more choice of filaments, and I'm really looking forward for the glass fiber filaments, because I never tried glass fiber filaments, and I really want to see what it looked like and how it performed. So that's I'm looking forward for this one.
We will talk about. I introduced quite properly the the ABS flame retardant. I think we can
Oh yeah,
speak a
Yeah.
bit about it. Yeah, so basically this is just, as the name states, it is a flame retardant filament. Flame, yeah, that's the question. Everything is in the name. Flame retardant means like it doesn't propagate the flames. For example, you will put it on fire, you put it out of fire, you will extinguish automatically, so which is pretty cool. Like for example, other filaments like ABS or PLA, they tend to burn and consume themselves all the way through. Flame retardant filaments will tend to self-extinguish, so it's very important for some applications. I have some big plans for you in the future when we will finally get our hand on those filaments.
oh yeah,
We can do some electronical projects.
Exactly.
That would be really nice.
that's what I was about to say. Is that what I really look forward with the flame retardant filament is that you can, like, the main use, at least for me, is to make electronic casing mostly. To put like Arduino board or any electronic, because since it's flame retardant, it's way safer to do, because in case of overload on the board or anything, it's, yeah, as Mathieu said, the filament won't burn, or at least will extinguish itself. So that's very nice, because if you print, for example, in PLA, which is on top of that very heat sensitive, if you have any problem, electronic problem on the case, it can just burn, and that's, I mean, I don't need to make it drawing. That's pretty bad. That can be pretty bad. So it's way safer to have a flame retardant filament. So I'm really looking forward. And
That's good. I need new headpads for my PlayStation 4. I will put you on this.
yeah, with pleasure. I'm looking forward to design something.
And Plenty said that I think he's speaking about you. That you
I mean,
look
there's
like
an S to guys.
19, yeah, 19th century scientist with a hat on.
I think it's the mustache. For both of us, it's the mustache.
Yes.
Yeah, it's kind of. We should put hats, maybe. Maybe we should. We should. But that's kind of what we are. 21st century, but that's kind of what we are. We are, I mean, scientists. We are not designing any of the Sunloop project, but not yet. But on stream, at least, we will try to do some weird project and designing some fun stuff. So we kind of are.
And just a final word about because we at Sunloop we really love carbon fiber. So we also have a series with PLA carbon fiber and PETG carbon fiber.
Yeah.
And people might think, what is the main purpose of having carbon fiber in PLA in PETG? And it's the result is very good looking, but the function is mainly aesthetic. The finish is very, very nice, but it doesn't add anything. It doesn't add much. So I cannot say it doesn't add anything. It doesn't add much to the mechanical property of a PLA, for example.
Especially for the PLA. Yeah. It's a bit more for the PETG, but it's way more for the PLA. Because usually what the carbon fiber does is that it tends to stabilize the print, meaning that there is less shrinking, for example, and you have a way better finish. It's sharper edge, and it overall look very, very good. You have way more precision. But on the PLA, it's less important because the PLA by itself is already very precise, very stable, very easy to print. So it's mainly aesthetic, and we are always showing you this.
This one is
on
nice.
Every stream we are showing you this one.
This one is really, really nice.
But you can see that it's very sharp. Like, it's very clean. The texture is very, like, okay, focus now. Yeah. See, there is almost no ringing at all. Like the edge are
And
clean.
you can see it's PLA carbon fiber just now.
Yeah. I revealed the secret. Anyway, it's like, it's clean. It's very clean. And this one is PETG carbon fiber. You won't see much, but basically it's like, it's also very clean, and the frosted texture make it look so like, you almost don't see the layer, and it's like, it's nice. Yep, music cut.
Oh, thanks a lot for Builder Mark for your message. However, I think Sunlow won't. I mean, in the close future, I think 3D printers is not our priority now. Now to be honest, is there's much more companies that does manufacture printers better than us. We acknowledge this, and we will remain on what we do best, like filament, resin, and accessories for now.
I mean, right now, if you want to start, I mean, not start because we already did in the past, but the market of printer is so advanced. There is such good printer available for quite cheap that it's a very close market.
And they put they achieve so high. I'm gonna say record, but so high. I forgot my English. They're really.
You
really
can
too
say
good.
it in French.
Yeah, maybe there's. I think our French bravery girl is there. We can speak in French a bit. No, now just to say that now the FDM printers are too much advanced. And it's too hard to compete with them.
And it's crazy to see the advancement of them. Like I love to see, for example, on a Prusa slicer, at every update, you discover a new thing about 3D printing, because you have, like, with the open source community, you have all kind of new invention, if I may, and every month there is a new thing, a new way to print, and it's moved so quick. It moves so quick. Like, I remember a couple of years ago when the tree supports were implemented, and now we cannot live without the tree support, for example. It's like, I don't know. It's so cool.
A small revolution.
Yeah, and so it's way harder now to catch up on that.
Yeah, true.
So we focus on making nice filaments. Heavy in density is carbon fiber, different from PLA. Actually, it would be interesting to... I don't know. Do we have the information here?
Yeah, you can check the information.
I don't know if the... What's the difference? Because I think there is 20% carbon fiber in the PLA. But I don't actually know if the PLA with carbon fiber is lighter or is heavier than the normal PLA.
Sorry, we prepared a bit of hacks because there's too much information too much filament, too much information to remember.
Do I have the...
I'll quickly answer. I saw Rafael Hernandez said he would love to have a Sunlu official store in Mexico. Official store, maybe not so fast, but maybe in the future, yes. We're working with distributor for now in Mexico, and I think you were able to find a good Sunlu product, and normally it should be cost competitive still.
Okay, so I don't have the density of the filaments, but basically I can see that on a 1 kilogram spool of normal PLA, you have 330 meters. And on a 1 kilogram spool of carbon fiber PLA, you have 300 meters. So basically you have the carbon fiber one is a bit denser than the normal PLA, so a bit heavier. It's 30 meters. It's not that much, but it's still a bit heavier. And that's interesting also because we talked about the PA12 and PA6 earlier, and Matthew mentioned that the PA12 was also lighter than the PA6. I mean, usually on prints, it's not as important because the parts are usually like not empty but hollow, and they are almost all the same weight depending on the volume, and the filament doesn't make that much change in the overall weight of the part. And airborne animation, you should stay tuned because maybe you will win the giveaway.
The giveaway,
later.
I think, gonna start quite soon.
Yeah.
Just I have a final word about engineering filaments. We said a couple of times now that usually engineering filaments are quite harder to print, a bit more trickier to print. That's why at Sunlu we also developed two different filament that we call like Easy PA and Easy ABS, which we make it more affordable, for one hand, because they are cheaper, also more easier for maybe people who are not used to use these engineering filaments to get into the engineering filament stuff. So usually the good thing is that they have mechanical properties that make them easier to print. Like for example, the Easy PA will tend to have better flow, and is also not warping at all. The Easy ABS has the good part of not needing an enclosure to print like the usual ABS requires. So we are also making efforts on that part to make engineering filaments available for everybody.
Yeah, basically, as you said, the Easy PA especially need to be print at a lower temperature than the normal PA, so it's easier to print. And it's also, since it's at lower temperature, there is also less warping, and also there is no carbon fiber in the Easy PA, which make it a bit less how can I say it, a bit less, I don't want to say dangerous, like it's better for the printer, because the carbon fiber, we didn't mention it, but the carbon fiber or any particle in a filament, like the wood, for example, the metal infused filaments, they tend to eat the nozzle way quicker. So you need to change the nozzle. And for carbon fiber, for example, you need to have a stainless nozzle at least, or a harder nozzle even, because if you print with brass nozzle, the nozzle will die in like no time. So Easy PA is good for that because it's less abrasive. Thank you, abrasive. That was the word I was looking for.
Yeah, that's
the word I was looking for. Okay. Thank you.
I think it's about time.
I just wanted to mention one last thing. Sorry. Since we are on the nozzle thing.
The diamond head? No?
Oh, the diamond. Oh yeah, we talked about it earlier.
I don't know how we came in the topic, but we were talking about I forgot the company again. A US company. If3D working with another company.
Oh, Diamond Black.
I forgot Diamond Black. I guess. I think it's this brand. And anyway, we were talking about they develop a diamond nozzle, which looks very, very nice, which also is quite expensive, but I think they have their...
I want to try it, I want to try it.
Yeah. we can request a budget.
Diamond Back.
Diamond Back.
Yeah, thank you.
True.
Yeah, but I just, before move on, I just wanted to mention something. Lucky. Okay. Send me some then. I just wanted to mention also that, we didn't really talk about it, but the PA especially need to be printed in an enclosure because it reached such high temperature and it need to be stable during the print, so it's way better to print in the enclosure. And also, since the bed is reaching way higher temperature, it need to be printed on certain time type of bed. So bed that will allow this temperature and bed that will stick more to the print. So for example, a satin or textured bed, depending of the printer, of course. And also always use adhesive that can reach the temperature also, but because otherwise it will be kind of a pain to print because of the warping. The PA, the normal PA, so PA 6 and 12, can be quite tricky to print. So that's why the easy PA is so nice, because the normal PA, PA 12 and 6 need, as we said, a lot of drying, need to be dried during the print. It needs a Narden nozzle, it needs a proper bed, an enclosure, and some glue, basically. So it can be quite tricky, but when it's done, it's look nice. And it's tough. It's really tough. Anyway, how do you align the carbon fiber inside the filament?
Actually, we don't need to align the carbon fiber because it's not powder, but it's scraps of carbon fiber that we mix with the whole inside the recipe, basically, and it's melt with the filament. So you don't need to align in a specific way. It's just included into the recipe. It's
some shard of carbon fiber.
Exactly.
You cannot do a long string of carbon fiber because otherwise, when you print and you stop, you would need to cut the fiber, for example. Or like, so at every layer, you would need to cut the fiber and then, so yeah, it's just some shard of carbon fiber. Anyway, I think now it's time to do the finally.
People are waiting.
People are waiting. People are waiting, and I didn't eat, and I'm hungry. So let's do this. So as we said, we have two winners. This time I'm gonna try to not mess up. One on Twitch, one on YouTube, and the first winner is gonna win a filament connector. Not this one. This is ours. But you will win a new one. A filament connector with 2 spools of engineering filaments. Do we know already which filament will it be?
I think it will be random picked.
Okay.
We can decide afterwards. People, you can let us know what you like, and we'll make sure, based on the stock we have at the moment, to give you
basically, it's the filament that we talk about today.
Yeah, exactly. You're not going to receive white PLA. Don't forget.
And the second winner will be winning the 2 kilogram of engineering filament. So no filament connector for the second winner. But maybe next stream, maybe. Who knows? Okay, I'm going to start the giveaway. So where do I go? Okay. It's starting. So you need to enter exclamation point connector, and then normally Streamlabs will send you a message to say that you are registered. Yeah, okay. Good luck. Good luck.
Okay.
Easy and 12, just a suggestion. Yeah. Just a suggestion. Oh my god. Okay, it's starting.
Is it working on YouTube also? Yeah.
Yeah,
it is working.
All the YouTube.
Builders Mark.
And then this is Twitch.
Okay. Good.
It's mostly YouTube. I mean, I can come here. How do I enter it?
Don't touch anything.
I don't want to finish it. I want to look at the entry. Okay, this is the entry. So for now, for example, we have 17 people that have their ticket, and that's it. We're waiting. I mean, I put 10 minutes, but we can make it more or less. We're just gonna wait for the people to enter the giveaway. What can we talk about now to fill the stream while everybody is
participating
in the content? Yeah. contest.
We forgot to answer the second part of the question of I forgot the name already. People were asking if we were working on new resins.
Oh, yeah, my bad.
Yeah, we have upgraded our high temperature resin, high temperature resistant resin, and for the beginning of the year, that's about it for now. Yeah, I don't think we have any new plans of resin for the beginning of the year. And for next live stream, or if the news come out, we will make sure to update you guys.
And yeah, also Builder Mark asked any new color. I don't know if you were asking for the resin or for the filament. For the resin, we have a bunch of color that came out recently that I didn't try yet. I need to try them. But for the filament, it's true that we didn't mention the color of the new filament. Basically, for now, the engineering filament will be black.
Yeah.
There is white too, I think, for the PCABS.
Yeah, exactly. So for some of them, they are, yeah.
And I'm not sure. I don't remember all the color that we have, but I think for the PCABS it's black and white, and for the carbon fiber for now it's only black. I saw some color filaments made with carbon fiber, so that would be a nice thing to have. But for now it's black.
Sorry, I quickly reply to Chris. What are the impact resistance properties? On the generic term, the impact resistance is the resistance for single blow punch. You can understand like this, and it's not in opposition to repeated stress like elongation or so. And for this, the best filament we have for impact resistance is the PCABS. In joules per square meter is 70, while regular PC is 35, something like this. So it's really quite impressive.
It's those filaments are very good for the impact. I don't know if you saw it, but there's a video of like the helmet. Where did I put it?
Yeah.
Oh yeah. Of us like hitting the helmet with an armor, and then it's very good for the impact.
It's very good for us.
I'm looking for the number, but I don't have it anymore.
Don't think you have it here though. Any plans to make a Discord server? This will need to check Nicolas' workload. He's already about to burst.
I mean, yeah, it's a good idea. The only thing is that for now, I don't really know what we would do with it, how we would use it. I want to do it, and so we can exchange on the print we are making, and we have a more direct connection. But I think we will do it maybe a bit later with the stream going on. But yeah, it's in the plan. We didn't do it yet. We will. But I think right now, if you want to chat a bit more, or to talk about the filament, the print, or to display your print, very simple. We always love to see the print. The best thing to do is to go on Reddit, on the r/sunlu on Reddit. It's not official yet, but you can still use it, and so that way I will be able to see everything that you're posting. So yeah, please feel free to go on Reddit.
And build the marks. When we have the Discord server, we'll ask you for help for moderating, or we definitely need some help too.
It's in the plan. I didn't found the data, but yeah, it's in the plan, but not quite yet. I wanted to say something else, but I forgot once again.
Oh,
I have a disc.
Sebastian, I created Discord, but we didn't have proper time to use it and to.
I wasn't there when that was made. So.
Oh yeah, that was a long time ago.
I mean, we will probably reuse this one, but
everything is there.
Yeah. For now, let's consider it closed, and when we will need it, when we will be ready, then yeah. Okay, I think it's 28 user. So if there is some late user, just feel free to.
2 minutes left. Maybe you can stay 2 minutes more.
I mean, yeah, there is 2 minutes.
Yeah,
so
let's
we can wait.
Yeah.
Is there any other question? I cannot go back on this one because I. Oh yes, silicone like would be very useful or something more flexible to be made into mold. To be made into mold, what could be? I mean, because we already have the high toughness resin, which can be quite flexible. We're going to talk about it a bit later on the next stream. We already talk about it in the first or second stream. It's like, depending on the design, it can be very flexible. It's not as flexible as silicone, but you can, depending on what you want to mold, you can already do it with 3D print, both FDM and resin. So I'm just trying to think about what would be the best solution. But if you use like a product to coat the mold to ease up the demolding, you can already do it with normal PLA, for example, or with resin. It will be way nicer. It will look way nicer. So high toughness maybe would be a solution for that. How well does the PA filaments perform for print in place model? As we said, it can be quite tricky to print. So if you manage to print it like nicely, it's very nice actually for print in place, because the carbon fiber, for example, the 6 and 12, since it's very stable, it's very good for the print in place filaments. I don't have example. Is this one the print in place? I don't remember. No, this one is not. But it can be quite tricky. But no, I think it perform. I didn't do it yet, but it will perform nicely for print in place. You
can show them in the next.
Yeah,
in the next live.
Yeah, I will try actually, because I'm on my way to make more engines.
Chris, feel free to come back to the next.
So
stream.
I will try to find some screw to finish this one, and I will make some other engine and maybe print in place one.
Nick was asking whether we are trying to focus more on engineering products with the launch of the new E2 dryer. It is true for the beginning of the year. Yes, it will be the main focus. Filament dryer E2 and the relevant engineering filaments for the first 4 months of the new year.
And we didn't talk about the annealing function because we already talked about it quite a lot on the last, not the last one, but the one before that. But yeah, those are like the PA specifically are very nice for that. It's that you can anneal them to make them even stronger. So that's nice. And this is all thanks to the E2 filler dryer. Okay, I'm gonna pick the winner. The winners. And hopefully I'm not gonna mess up. So that's perfect. Okay, I'm happy because now I picked 2 winners randomly, and it's one on YouTube, one on Twitch. Good. So the first winner is on YouTube for once. Usually it's Twitch.
Yeah, usually it's Twitch.
And it's where are you? It's Wen. W-E-N on YouTube.
When? Where is when?
Can I tag you? When? Yeah, it's you.
You won.
GG when. If you're still here. And I think it's kind of cheating because I remember this name. But the second winner on Twitch is Space Core. Didn't you already win something, Space Core? I mean, you can have it. Like, it's not... But I think you already...
It doesn't ring a bell to
won.
me though. Maybe he will. Maybe he will say if he wants something. Congratulations, guys.
That's for being loyal. So
yes.
So thank you.
Literally.
And I believe that Mark, you will win also one day.
Yeah, we're picking two at a time. Yeah.
Okay. Yeah, you did. Okay, that's. So as always for YouTube. So when you need to contact us on Instagram with the proof that you are the owner of the account. I always forgot how you do that. I think maybe Tim in the chat can tell us. And for Space Core, you don't have to do anything because
you remember you, I guess.
Twitch. So and yeah, we have. I think we already have your information anyways. I'm gonna contact you directly on Twitch. So have your DM open though. What did you win already, Space Core? It was.
Was it last one? Or
no,
the one
I think
before?
it was Filaments 2.
But one of the first. Filament. Is it?
Filament, yeah. It's when we made the E2 giveaway, and you were the second winner, but you were on YouTube. Oh my god, such a cheater.
He's everywhere.
Anyway, okay. So yeah, do that. Send us the information for when on Instagram or LinkedIn or Reddit or wherever you want, but send us a message. Not by mail, just like Instagram, LinkedIn, Reddit. That's about it. And also, yeah, send it on Instagram. And for Space Core, you don't have to do anything. Twitch Whisper, exactly. Have your Twitch Whisper open. Okay, then I guess we will see each other
in 2 weeks.
Wednesday, 8 p.m. Or we will also see each other maybe earlier, maybe next week or the week after. I don't know. I don't even know how to advertise it. But basically, we will see each other on Twitch, not YouTube, only Twitch. And we will see what we are gonna do. Okay. Well then.
Thanks guys for participating today, for sharing this 1 hour and 10 minutes ish with us. It was a pleasure. It's always good to see that you are participating a lot in the chat. That's always
so pleasant.
That's very pleasant for us. And also, if you guys want us to talk about one topic in particular, whether it is more for a short live or a long live, just feel free to let us know. We'll be happy to implement this.
Yep.
And yeah, that's basically
that's about it.
That's about it. See you guys.
Okay. See you.
Good evening.
See
bye
you.
bye.
And
see you in 2 weeks.
Stay tuned. Okay, I need to learn how to
close
start
it.
Okay, this is the ending screen. Okay. Okay, see you.
See you. Bye.